So in this lesson, our focus is going to be on multiplying decimals by using the standard algorithm. So we've been working on a lot of strategies up until this point on how to multiply decimals. You've learned how to multiply decimals using partial products. You've learned how to multiply decimals by using commutative and associative property. We've really been looking at the patterns of decimals with place value. But today we're going to kind of bring all of that together and walk through the standard algorithm and show you guys how you multiply using that standard algorithm. Now, if you recall back in topic 3, we talked about an algorithm. So, an algorithm is a step-by-step process in which we do an operation exactly the same every time. So when we multiplied whole numbers, we multiply the ones place, and then once we're done with that, we use a placeholder and multiply the tens place, and use a placeholder and multiply the hundreds place. Well, the decimal standard algorithm is pretty simple. We're going to multiply as we would with whole numbers, and we're going to ignore the decimals until the end. So if you remember that we need to ignore the decimals until the end, it will make it much easier to work on your standard algorithm. It says Melissa is making fruit punch. She wants to make 2.5 batches using the recipe shown. How much cranberry juice should Melissa use? So she needs 1.5 liters cranberry juice, and she's doing 2.5 batches. So we're going to walk through the standard algorithm and multiply and see what this is going to look like. So first thing we're going to do, just to help us check with reasonableness, is we're going to estimate. So 1.5 I would round to 2, 2.5 I would round to 3, and I should get an answer of around 6. So she needs 6 cups or 6 liters of cranberry juice. Now to set this up, I'm going to set it up as I would multiply whole numbers. And I'm going to put the decimal in. So I'm going to do 2.5 multiplied by 1.5. It doesn't matter. Decimals don't have to be lined up. They're lined up in this case because I have 2-digit values, but the order of the decimal does not matter like it does in addition and subtraction. So the first step I'm going to do is I'm going to multiply the 5s together. So I'm going to do 5 times 5. I get 25. I regroup the 2. Same process I'm going to use when I multiply whole numbers. I'm now going to take the 5 and I'll multiply it by the 2. So 5 times 2 is going to be 10. I add my regrouping. I get 12. Notice again, I'm ignoring that decimal. I'm not doing anything with it. I only worry about the decimal at the end. Okay. Now I'm going to multiply by this value right here by the 1. So I'm going to do 1 times 5, which is going to be 5. And then 1 times 2, which is going to be 2. I'm going to add those together. And when I add those together, I get 5, 7, 2, 3. Okay, so I get 3 and 75 hundredths. And how I figured out that I'm going to have 3 and 75 hundredths is I had one value behind the decimal here, one value behind the decimal here. So each number of numbers I have behind the decimal in each one of my factors tells me how many numbers I need to have behind the decimal in my product. So I had 1, 2. That tells me in 375, I need to make that 2 numbers behind the decimal. So the decimal is going to go between the 3 and the 7 to make 375 hundredths of a liter of cranberry juice is what we'll need. 375 hundredths is near 6, so the answer is going to be a reasonable answer. All right, so let's go ahead and take a look down at the convince me. So the convince me says to look for relationships. It says how many tablespoons of sugar does Melissa need? Explain how you found the answer. So we're going to go back up to the recipe, and she needs 6 tablespoons of sugar. So what I would do is I would take 2 and 5/10. And I'm going to put this one on top because I'm multiplying a 2-digit number, even though it's a decimal, by a 1-digit number. So she had 6 tablespoons of sugar. So I'm going to go ahead and I'm going to multiply. Again, I'm not going to do anything with the decimal until I need to, which is at the end. So I ignore this decimal until the end. I treat it just like regular multiplication, and then I worry about the decimal at the end. So 6 times 5 is going to be 30. So put down the 0, regroup the 3. 6 times 2 is going to be 6, plus 3 is going to be 9. And then I look at the number of decimals I have in both factors. Well, in 2 and 5/10, I have one number behind the decimal. And in 6, I have no numbers behind the decimal. So altogether, I have one number behind the decimal in both factors. So that tells me my decimal is right here outside of the ones place right now. It needs to go between the 9 and the 0, and my answer is 9 tablespoons of sugar. So we found the answer by multiplying 6 by 2.5 and then placing the decimal between the 9 and the 0 because I had one value behind the decimal in both factors. Okay, so let's go ahead and move on to your guided practice. And so when we take a look at your guided practice, this is a good one to look at. Okay, so if I'm looking at 5/10 multiplied by 3/100, I treat it just like regular multiplication. Notice here, the decimals are not lined up. The decimals, when I multiply, do not need to be lined up. So I'm going to go ahead and multiply. 3 times 5, I get 15. But here, I have one number behind the decimal. Here, I have two numbers behind the decimal. So I need to have a total of 3 numbers behind the decimal for my product. Okay, if I don't have one, you'll notice that this 0 is in red. That means I have to add a 0 in front of 15 to make it to where I had enough. Okay, so we'll take a look at this as we go through and multiply and see what it looks like. All right, so if we take a look at number 1, says Sasha wants to multiply 5/10 times 8/10. How many decimal places will the product have? And explain. So again, I look at how many decimals I have in my factors or how many digits I have behind the decimal. So in 5/10, I have one value behind the decimal, and in 8/10, I have one value behind the decimal. So that means if I have one value behind the 5/10 and one value behind the 8/10, I'm going to have two decimal places because I had two decimal places in my factors. So I need to have two decimal places behind the 0 in my product because my factors had two decimal places. Okay, so let's take a look at number 2. If 112 times 38 is 4,256, what is the product of 1 and 12 hundredths multiplied by 3 and 8/10? So again, I look at the total number of digits I have behind the decimal in both factors. So 1 and 1/12, I have 2 digits behind the decimal, and then 8/10, I have 1 behind the decimal. So for a total of 1, 2, 3. So my answer for this one is going to be, for number 2, is going to have 4 and 256 thousandths because I should have 3 values behind the decimal in my product because I have 1, 2, 3 values behind the decimal in my factors. We're going to go ahead and do some work on there. So use number sense or estimation to check your answer. Number sense is really going to be looking at that estimation to see if it's reasonable. So I'm going to have 12.5 multiplied by 9 hundredths. Again, the process I'm looking for today is I'm looking for your use with the standard algorithm. So you need to show me your work if you need to do that on another page and staple it to this, and that's what you're going to need to do. So if I have 12.5 multiplied by 0.09, I'm only going to multiply 12.5 times 9 and just worry about this 0 when I factor in the number I have behind my decimals, my products. So 9 times 5 is going to be 45. So I'm going to put down the 5 and regroup the 4. 9 times 2 is going to be 18. 18 plus 4 is going to be 22. So I put down the 2. I regroup the 1. 9 times 1 is going to be 9 plus 1 is going to be 10. So now I go back and now I worry about the decimals. Again, you'll notice I didn't worry about the decimals. I don't automatically assume that the decimal is lined up down here. I only worry about lining up decimals when I'm adding and subtracting, not multiplying. When I'm multiplying, I worry about the decimals after I have multiplied. Then I determine where the decimal placement is going to go. So 12.5, I have one value behind the decimal here. I have one value behind the decimal here and one value behind the decimal here for a total of 1, 2, 3 places behind the decimal. That means if I have 3 numbers behind the decimal in my factors, my product needs to have 3 numbers behind the decimal. So my answer is going to be 1 and 25 thousandths. Okay. We take a look at number 4. We have 9 and 1/10 multiplied by 6 and 8/10. So I will go ahead and do estimation on this one. So I have 10 multiplied by 7. So my answer should be near 70. So let's see when I go ahead and multiply. Again, when I multiply, I don't worry about the decimals. I just treat them like they're not even there, and then I worry about them at the end. So 8 times 1 is going to be 8. 8 times 9 is going to be 72. I put down my 0. 6 times 1 is going to be 6. Notice I ignore the decimal. 6 times 9 is going to be 54. I'm going to add my values. So I have 8, 8, 11, regrouped 1, 6. So now I have to worry about the decimals. I have one value here behind the decimal and one value here behind the decimal for a total of 2 digits in my factors behind the decimal. So my product needs to have 2 digits behind the factors, which means my answer is going to be 61 and 88 hundredths. When I compare that to my estimation, my answer is reasonable. I have 8 tenths multiplied by 5 and 4 tenths. So I'm going to do 5 multiplied by I'm going to go ahead and do 0.8 as my estimation. And so 5 times 8 is going to be 40, one value behind the decimal. So my answer should be near 4. So let's see where I'm at. So I do 5 and 4 tenths multiplied by 8 tenths. Notice I put the 8 tenths on the bottom because, again, really I'm only multiplying by the 8. The 0 is a placeholder, so I don't want to have to multiply it, which is why I put it on the bottom. I can use the commutative property to order my decimals any way that I want. Okay, so 8 times 4 is going to be 32, so I'm going to put down the 2, regroup the 3. 8 times 5 is going to be 40, plus 3 is going to be 43. All right, now I look for the number of values behind the decimal. So I have 2 numbers behind the decimal total in my factors. So my product needs to have 2 numbers behind the decimal. So it's going to be 1, 2. So my answer is going to be 4 and 32 hundredths. All right, my last problem, I'm actually not even going to set up using the standard algorithm. I'm going to use place value to work on this. So I'm just going to do 4 times 7, and I get 28. Because it's a basic multiplication fact, and then I don't want to have to worry about placeholders. So I have 28, but if I look here, I should have 1, 2, 3 numbers behind the decimal. So if I start over here in my ones place, which is behind the 8, and go 1, 2, oops, I ran out of numbers, so I'm going to add a 0 in front. So now it's 1, 2, 3. My decimal goes right there. So my answer is going to be 28 thousandths. So what you're going to do now is you are going to work on your independent practice. And on your independent practice, you are only going to do some of the problems. You're not going to do all of the problems. You are going to do problems 8 through 14 even. And then you're going to do all of 15 through 19. Okay. And then we will work on this standard algorithm more when you guys come to see me in group.